classroom. In this model number 4, we are focusing on batteries and its end-use e-vehicles. So now we will look into the basics of batteries. Okay, so in this lecture, we are going to discuss about or recall what we have know already about the batteries. What is the purpose of a cell? What constitutes a cell? That is, what are the different components that are present in a cell? What is the purpose of each cell? And what are the different type of cells that are available? And what is the main difference between the dry cells or wet cells or primary cells or secondary cells? And what is the significance of each component, that is anode, cathode, and electrolytes in a battery? And what is primary cell, what is secondary cell? All that we will discuss. Okay, and we look into the chemistry behind it and the thermodynamics behind battery, and we look into some of what is galvanic cell and what is the difference between galvanic cell and voltaic cell, and we will see some demonstration videos regarding batteries in this particular lecture. Okay, so in this process you will be able to differentiate between primary batteries and secondary batteries, for dry cells and wet cells, and we will learn about anode, cathode, and electrolytes for batteries. Okay, and what are the mechanism behind it? All that will be discussed in this lecture in detail. Okay, so the textbooks that have been referred are some of the books which are available in Amazon also. Crompton, author, Battery Reference Book, 3rd edition. Jianmin Ma, Battery Technologies, and Lithium Batteries, Science and Technology by Nazri. I think the third book is more. So this third book is most commonly used as textbook for separate courses on batteries. That will be like textbook model. Other are reference book types. Okay. So however, we have been learning about these batteries since our school days. It's only first we will be refreshing this. Okay. So we know the batteries are being used as the power source. Either it may be primary at some places or it may be used as secondary power source at some places. So that means standby mode. Okay, we know that a battery consists of several number of cells, okay, and which will be assembled in a common container and which will be connected together to give a required output power, right? So depending upon the output power required, we will be having number of cells connected. So the learning objectives for this lecture is, so we will recall, already we have learned about EMF series, voltaic series, and we'll recall what is a cell, what is the building block of all the batteries, and what constitutes a battery or cell, and how to combine them to get a required voltage, current, and power, and what is the chemistry behind that. Okay. So we know that to start with, we know about the electromotive EMF series, which is a list of metals ranking with respect to its inherent chemical reaction, that is chemical reactivity, right? And we know that galvanic series and electrochemical series also there. And the difference between them is the galvanic series depicts the order of nobility of a metal and semi-metals, whereas the
Sir,
yes.
sir, your voice is not clear, sir. There's some noise.
Is it okay now?
Sir, it is like a heavy voice, sir.
Should I reduce voice or you want to say hello?
Sir, I cannot. Sir, it is not clear. Maybe due to some mic issue, it may be, sir. But
That's what I have reconnected. 1 second. Hello, hello. It's showing okay. Is it okay now?
yes, sir. Now it is fine.
Hello, am I audible now?
Yes, sir. It's clear now, sir.
Okay. Okay. So we know about this electrochemical series where we have a list. If you look at this list, starting from lithium, potassium, calcium to gold, if you look at left hand side, it is written metal reducing activity increasing. That is reduction capability increases. Whereas if you go from top to bottom, the oxidizing ability increases. Okay. So accordingly, we have the EMF that can be generated when you use that one can be seen here. Okay, so actually if you have strong oxidizing agent starting from fluoride to lithium, that is if lithium, if you look at the right hand side, you can see that stronger reducing agents. So which means that here at the bottom of the list you see lithium, which is the strong reducing agent. Whereas in the left hand side, the same only, not 2F. So F2, that is the good oxidizing agent. Okay, so by observing this electrochemical series, one can easily distinguish between a good oxidizing agent and reducing agent. And the oxidizing agents possess the positive value of standard reduction potential and which appears on the top of the series, whereas the reducing agents are located at the bottom of the list and they have a negative value of standard reduction potential. Okay, and some of the points which we have learned in our school days also, just to recollect them. So the electrochemical series takes an element's reduction potential in reference to the hydrogen scale. For hydrogen it is assigned as 0. So with respect to hydrogen, we arrange them in order. So the definition of an element's standard reduction potential is the measure of an element's likelihood to undergo reduction. So the larger an element's reduction potential, the easier it is to reduce. Elements with a low reduction potential, on the other hand, will be oxidized considerably more quickly and easily. So if you have a strong reducing agents, they will have a negative standard reduction potential. They are typically found in the electrochemical series below the hydrogen. In a series, however, weaker reducing agents with positive standard reduction potentials are identified above the hydrogen. So as we travel down the group, the strength of the reducing agent increases while the strength of the oxidizing agents drops down. Similarly, as we progress through the series, the electropositive and activity of metals increase or intensifies. It reduces in case of the non-metals. So how to get the standard EMF of an electrochemical cell? We know that. So the standard oxidation potential is equal to opposite of the standard reduction potential. Also we know the standard EMF is equal to standard reduction potential of the reduction of the cell minus standard reduction potential of the oxidation of the cell, right? So to EMF of a cell can be calculated that way. Okay, and as I told, what is galvanic series? It also ranks the reactivity of metals or alloys in seawater. Okay, so you can see that starting from more noble metal which can be used as cathode and more active materials which can be used as anode. So at the bottom of the table you can see magnesium, zinc, cadmium, aluminum, iron, lead, tin, etc. And more noble metals are platinum, gold, even palladium can be added there. Okay. So when you connect them in series, remember this galvanic series reactivity changes with the environment, right? So this is arranged particularly with the seawater. So when you are having different environment, you are going to choose accordingly the materials to be connected. Okay. So for example, in most of the example, zinc and copper are used as the combination of metals. So if you zinc and copper, the one below will be acting like anode, the one above it will act as a cathode. So for example, if I use platinum and copper, so copper will act as anode, platinum will act as cathode. Okay, so that way here, if you in between zinc and copper, zinc will act as anode and copper will act as the cathode. So that is the movement of ions will be taking place from the anode material to cathode material. That means you can see here zinc and copper. You have zinc is anode, copper is cathode. Okay. So there are several ways to remember the electrochemical series. There are that we will not consider here. So in a battery or a cell, what is happening? The movement of ions is taking place through this one. So the electrons will be moving through the external circuit. Okay. This is similar. Already we have discussed in detail about fuel cells. So these are all same thing only. So here the difference is in batteries we are having chemicals which are going to exhaust, whereas in fuel cell we are continuously supplying. So that way we have continuous output. Okay, so let's see what is a cell. What cell here refers to galvanic cell. When you simply say cell, because microbial cells also there, right? So here when we say cell, it is a galvanic cell. What is a galvanic cell? It is a device that transforms the chemical energy into electrical energy. And the simplest cell, which is also known as galvanic cell or voltaic cell, is shown in this figure. What we will have is a carbon. We will have a carbon and we will have a zinc, and they are both are suspended in a jar which contains a electrolyte solution. We can have some acidic medium, so that is sulfuric acid in water. So that will form the electrolyte, and this is the fundamental unit of the battery. And we know each cell consists of two electrodes placed in a container that holds the electrolyte, and that is connected externally for the electrons to flow. And in some cells, the container itself acts as one of the electrode rather than a neutral container. The outside container will act as one of the electrode, and the other electrode will be present at the center. Okay, so that also can be done when you design accordingly. So this galvanic cell or voltaic cell is an electrochemical cell which converts the chemical energy to electrical energy from the spontaneous redox reactions. When you say redox reaction, what is that? Reduction and oxidation. So reduction takes place at anode, reduction takes place at cathode, oxidation takes place at anode. So to remember that, you can say, so at anode we will have oxidation taking place, at cathode we will have the reduction taking place. Okay, so the reaction is a Faraday reaction, which is defined as the reaction involved with electron transfer from or to the electrode to the or from ions. In an electrochemical cell, there are two off cells which are giving or receiving electrons to the electrode respectively, leading to a neutral overall reaction. Okay, so even we have hydrogen flow batteries. So in a hydrogen flow battery also we are going to have a different anode and cathode reaction. So if you consider example of hydrogen flow batteries, hydrogen bromide flow battery. So in that also we will have hydrogen flow battery. When we say hydrogen and bromide are being circulated continuously into the system, similar to fuel cell. Okay, so the reaction that is taking place at the anode side is hydrogen will form H plus ions and electrons. This cathode off cell reaction is, so bromide is being supplied. So when you supply bromine here to the side, so it will form hydrogen bromide. Okay, and then overall reaction that is taking place, if you balance it, you will get hydrogen plus bromide reacts to form hydrogen bromide. Okay, so it will have a proton exchange membrane. So that is the hydrogen flow batteries are similar to your the flow battery is one in which your chemicals are continuously supplied. That's why it is called a flow batteries. Okay, so we will be continuously supplying the reactants to the system. Okay, there are some advantages associated with these flow batteries. The Hof's reaction in the cell will have faster kinetics, and we have this bromide will dissolve quite well, which is good for high concentration of the reaction species. When you have high concentration of reaction species, more absorption at the reaction active site will take place, and more electrons will be released, or more faster will be the kinetics. Okay, and this type of reactions cell construction is also very cheap, and there are some shortcomings with respect to these flow batteries. You have hydrogen bromide, and bromide can corrode the PEM fuels film which you will be using as the electrolyte. One of the way to solve that problem is to make the cell membraneless. That means we can try to make use of alternative electrolytes, okay, instead of membrane. And however, there will be issue of crossover problem. You can just correlate with a direct methanol fuel cell. Similar to that, here also there will be a crossover problem, which means the reactants at the anode or cathode can go to the other side and degrade the performance of the cell. Okay, so we will discuss about flow batteries in detail later. So if you want to make equivalent electrolyte, if you want to make an diagram for this one, flow diagram for this, so we can have that anode will be there, electrolyte will be there, and cathode will be there. Through external circuit, electrons will be flowing, right? So at anode, oxidation will take place. At cathode, so you have reduction taking place. Okay, So the parts, what are the components that makes a cell? So anode. So what is anode? It is defined as an electrode through which the positive or negative electric charge flows into or out of a polarized electrical device. In case of the electrochemical cell, oxidation reaction occurs at the anode, which producing the electrons, that is negative charge, that will be flowing out of the cell through the external circuit. With respect to cathode, is defined as an electrode through which a positive or negative electric charge flows out of or into a polarized electrical device. In the case of this electrochemical cell, a reduction reaction occurs at the cathode surface, which will consume the electrons that is coming through the external circuit. And what is an electrolyte? It is an insulator for electrons, but a conductor for the oxidized or reducing species, migrating from anode or cathode to anode, cathode or anode, which keeps the charge neutrality in the cell. And what is an electrolyte? The electrolytes are the conductors by which the current leaves or returns to the electrolyte. In the simple cell, they are carbon and zinc strips that are placed in the electrolyte, while in the dry cells, they are the carbon rod in the center and zinc container in which the cell is. Earlier also I told you, it is possible to have two electrodes and a common container, or one of the electrode can be electrode and container can also be the one of the electrode, right? So that is the example of a dry cell you can see here. So the container is made of one of the electrolyte, which is zinc container, which is a negative electrode, that is the anode, and you have positive terminal is the so you will have a carbon, so carbon stick, which is used as the one of the electrode here. Okay, so we have seen what is electrolyte. The container, as I said, it can be constructed from made up of different material, but it should be chemically neutral if it is not an electrode, right? Also, sometimes this container is used to mount the electrodes. In the voltaic cell, the container must be constructed of a material that will not be acted upon by the electrolyte. So it should be corrosion resistant, chemically inert, right? And also it should be able to have the withstand the thermal instabilities. Okay. And if you want to have a equivalent circuit, electrical equivalent circuit of this electrochemical cell is always given. So assuming constant internal resistance, you know the according to Kirchhoff's law, V equal to IR, right? So this circuit diagram can be equivalent of a electrochemical cell. So it will be a constituting a resistor unit and a capacitor unit. Okay. And we have already discussed about what are the different over potential, because whatever is the theoretically attainable voltage or output will not be attained even in batteries, and which will be due to polarization. Okay, so we have discussed in detail about polarization in the fuel cell lectures also. So there are three type of polarization may be possible, right? One is activation polarization due to chemical reaction, mass transfer polarization due to ion transport, or due to ohmic resistance due to external circuit, right? So that is. So what is polarization? We have discussed in detail during fuel cell course also. So if you remember, so the chemical action that occurs in the cell while the current is flowing causes hydrogen bubbles to form on the surface of the anode, and this action is called polarization. Some of the hydrogen bubble will rise to the surface of the electrolyte and escape into the air. Some of them will be remaining on the surface of the anode. So when you have enough bubble remaining on the anode, it is like a resistance, right? So it will not allow the reaction to take place, because the active site that is available, which is supposed to be freely available for the reactant to get absorbed and get the reaction happen. But when you have a bubbles, hydrogen bubble formed and sticking onto the surface, it is increasing the internal resistance. Okay. So when the internal resistance of the cell increases, what will happen to the output current? The output current will decrease, and obviously the output voltage will also decrease. Okay, so when you have a cell which is heavily polarized, which will not give any useful output, voltage output. Okay, so how to prevent the polarization or how to depolarize the cell? There are several methods. One is to vent out the cell to allow the hydrogen to escape into the air. We have to remove the whatever hydrogen is being formed that needs to be escaped. And however, there is a disadvantage associated with this method. So we don't have we are wasting the hydrogen that is formed. This hydrogen is not available to reform into the electrolyte during the recharging process. So how we can solve this problem? This can be solved by adding some water to the electrolyte, such as an automobile battery. That's why we often fill with the distilled water in our inverter batteries at our home. The second method is to use material that is rich in oxygen, such as manganese dioxide, which will be supplying free oxygen. So what happens to there? Hydrogen and oxygen will combine and it will form water. And that's why manganese dioxide is added to the system. And there is a third method which will use a material which can absorb the hydrogen, such as calcium. So the calcium will release the hydrogen during the recharge process. Okay. So these three methods will remove enough hydrogen so that the cell is practically free from the polarization. And there is one more thing called local action. So we ideally what we say, when you have the external circuit, as long as electron is flowing, you will have the system, right? Once you short circuit or when you stop the system, there is supposed to be zero electric current flow. But what happens actually is, since one of the thing is impurities are present. So for example, commercial zinc will contain impurities such as iron, carbon, lead and arsenic. Okay. So when the external circuit is removed, we are supposed to have uh, zero flow of electrons. Okay. But that is what theoretically supposed to be. Theoretically, even the chemical action within the cell should be stopping. But when there is such sufficient impurity present in the system, what happens is, even though we switch off the system, the chemical action will continue. Okay. So even though it is not loaded, there will be continuous chemical reaction taking place. So that means there is flow of electrons also, right? So that is called a local action. So how to prevent this local action is, obviously, when you want to use the zinc, use a pure zinc. But it is not possible. But what you can do is, you can coat it with mercury, or by adding some small percentage of mercury to the zinc during the manufacturing process of the zinc. So the treatment of zinc with mercury is called as amalgamating or mixing the zinc. Since mercury is many times heavier than an equal volume of water, small particles of impurities weighing less than the mercury will be floating to the surface of the mercury. So that way we are removing the impurities from the zinc, which will prevent the local action. Okay. But also this mercury is not readily acted upon by the acid. When the cell is delivering current to the load, the mercury continues to act on the impurities in the zinc. So which will cause the impurities to leave the surface of the zinc electrode and will be floating to the surface of the mercury. So that will generally increase the storage life of a battery or cell. So what is a cell? A cell is a device that transforms the chemical energy into electrical energy. The cell has three parts, that is the electrodes, that is electrolyte and the container. And there are two basic type of batteries, primary batteries and secondary batteries. What is the difference between primary and secondary battery? We'll discuss. Okay. So what is an electrode? They are the current conductors of the cell. Electrolyte is a solution that acts upon the electrodes. And not only solution, sometimes it is membranes also, right? We have seen in flow batteries, membranes are being used. And the container is the one which holds the electrolyte and provides a means of mounting the electrodes. And what is a primary cell? It is a cell in which the chemical action finally destroys one of the electrodes, usually the negative one. Okay. So the primary cell cannot be recharged. And whereas in the secondary cell are rechargeable batteries. Nowadays everyone using the rechargeable batteries, so that's why we going to discuss about secondary batteries in detail. Okay. So the secondary cell is the one in which the chemical action alters the electrodes and electrolyte, and the electrode and the electrolyte can be restored to its original condition by recharging the battery. So that way these are non-rechargeable, these are rechargeable. This one time use and throw batteries, these are recharge and keep using it. Okay. However, the capacity of the battery reduces with its uses, number of cycles that we are using, which we have discussed in detail earlier also. So how many times? Say for example, 500 times if you charge and recharge, initially if it gives a particular power output, later it will keep decreasing. So there is 20% reduction in its capacity. So then we can say the life of the battery is over. Okay. So the primary batteries, the reactions will be occur only once. In secondary batteries, the chemical reactions are reversible, and these primary batteries are the source of direct current power, and this voltage output from these type of batteries can range from 1.25 to 1.5 volt, which is used in the torches, radios and watches, etc. And they are low cost, and but their life is short. Okay. Whereas in case of secondary batteries, it's a the reaction or reversible reactions. That means that the electrodes and electrolyte will come back to its original position when you are doing the recharge. Okay, so these cells can be recharged by the electric current. Secondary cells are widely used in vehicles. Okay, electric and hybrid vehicles, smartphones, digital cameras, laptops, etc. Okay, so this is a Daniel cell. We know about this. We have seen that zinc and copper are used to demonstrate what is the cell. When the half cells are placed in two entirely different and separate containers, so we use a salt bridge to connect them. Okay, so the salt bridge typically contains high concentration of potassium nitrate. So that salt should not take part chemically in the reaction. Okay, either cell in the zinc or copper. Okay, so how to demonstrate a particular battery, how it performs is go. So in this demonstration, we are going to discuss about galvanic cell, voltaic cell, particularly zinc copper cell. So in this experiment, we can see there are two beakers in which zinc sulfate and copper sulfate solutions are taken, and we are having a zinc plate and copper plate which will be used as the electrodes, and these two electrodes, zinc and copper, are connected to the multimeter, okay, to note down the voltage. And we will be keeping the zinc in the zinc sulfate solution, and we will keep this copper electrode into the copper sulfate solution. So what happens? The zinc will oxidize and the zinc ions will enter into the solution, and whatever electrons is formed, that will remain on the sheet, and as it is connected to the external circuit, so these electrons will pass through the external circuit and reach the copper surface. So copper ions and copper sulfate will absorb them and will become a solid metal copper. So copper gets reduced. The multimeter will be showing till now 0 readings because these two electrolytes are not connected through a salt bridge. So when you use a towel, a paper towel as a salt bridge, so then only the charge equalization will take place and the current will flow. The moment we again remove this salt bridge, the charge equalization will stop, and so the current flow also. So for these electrons to flow or the electricity to be produced, so these not only salt bridge is important, these two metals sheets should be kept inside in their respective solution for the cell to operate. And when you have n number of cells in series, we call it as batteries. So that is the purpose of this demonstration. What is the chemistry behind this galvanic cell made up of zinc and copper? We have seen that the anode consists of zinc kept in zinc sulfate solution, and cathode consists of copper immersed in copper sulfate solution. If you consider a salt bridge made of containing NaCl, that is Na plus ions and Cl minus ions, so what happens during the reaction? Once the circuit is complete, there will be flow of electrons from zinc to copper. Why? Because zinc is a more active metal than the copper, so it is more likely to lose the electrons. So that means zinc rod is oxidized and it will release zinc ions and 2 electrons. And copper ion in the solutions in the right hand side, that is in the cathode side, will receive these 2 electrons through the external circuit and they will form copper metal. So these excess negative sulfate ions are being created in the catholyte solution, and what happens to neutralize it? Na plus ions from the salt bridge will be moving towards this copper sulfate solution side, that is catholyte side. So what will happen to the chloride ions? So the chloride ions from the salt bridge will move towards the zinc sulfate solution, that is anode side solution, which is anolyte. So thereby it the neutrality is maintained in zinc sulfate and copper sulfate solutions, and this reaction will proceed until either the zinc bar or the copper ions are depleted. So we can write down the overall reactions as shown here. Lead acid storage battery is commonly used as storage battery or secondary battery. The materials used for the lead acid storage battery are lead peroxide or lead dioxide, sponge lead, and dilute sulfuric acid. So the positive plate, which is lead peroxide, will look dark brown, hard and brittle substance. Whereas the negative plate, which is made up of spongy pure lead, will be made up of soft sponge. And the dilute sulfuric acid used in this lead acid battery has a water is to acid ratio of 3 is to 1. And this lead acid battery is formed by placing lead peroxide and spongy pure lead in dilute sulfuric acid. So these lead peroxide and spongy lead are connected externally through a load. So that load is connected externally between these two plates of lead peroxide and spongy lead. What happens to the electrolyte sulfuric acid? So that will dissociate into H plus ions and sulfate ions. So this H plus ions will reach the lead peroxide electrode, and there it will receive electrons and it will become hydrogen atom. So this hydrogen atom will react to form lead oxide and water. So this formed lead peroxide also reacts with sulfuric acid to form lead sulfate and water. The negative electrodes, negatively charged ions, sulfate ions, which are free to move in the solution, will be reaching the spongy lead electrode, and there they will release extra electrons and will become radical sulfate. This radical sulfate cannot exist alone, so they will attack the lead and they will form lead sulfate. And due to the inequality in the electrons, there will be external flow of current through the external circuit. So this is called as discharging of lead acid battery. And for recharging, we will disconnect the load and we will connect the positive terminal of a DC source to the lead peroxide electrode, and negative terminal of the DC source is connected to the spongy lead electrode. So what happens to this? The density of the sulfuric acid will fall and still sulfuric acid will exist in the solution. Then H plus ions and sulfate ions will be there. Now this H plus ions will reach the lead electrode and hydrogen atoms are formed. So lead sulfate and these hydrogen atoms will combine to form sulfuric acid and lead. So the sulfuric acid will reach the solution. Well, similarly, these free negative ions, that is sulfate ions, are free to move towards the positive electrodes, that is at lead peroxide electrode, and it will form radical sulfates. This radical sulfate will react with the lead sulfate of the anode and it will form hydrogen sulfate. 3, 2, 1, go. A typical sealed lead acid battery will consist of 6 cells mounted side by side in a single case, and these cells are coupled together, each having 2 voltage. It adds up to overall 12 voltage capacity of the battery. So even though this battery is heavy, these lead acid batteries are still preferred over other lightweight options because they are able to deliver large surges of electricity, which is required to start a cold engine in an automobile. A completely charged lead acid battery is made up of stack of alternating lead oxide electrodes isolated from each other by layers of porous separators. All these parts are placed in a concentrated solution of sulfuric acid, and intercell connectors will connect the positive end of one cell to the negative end of the next cell, thus making it an series, 6 cells in series. And what is the difference between galvanic cell and Daniell cell? We should know, because a galvanic cell is an electrochemical cell that uses electrical energy generated by spontaneous redox reactions. The main difference between the Daniell cell and galvanic cell is that the Daniell cell will use only copper and zinc as electrodes, whereas a galvanic cell can have a variety of metals as electrodes. Now let us look into what is happening during charging and discharging of a lead acid battery, because the electrodes as well as electrolyte keep changing its nature during the charging and discharging cycle. So let us look into it. So you can see what is happening during the 4 stages of this battery, charging and discharging. This is particularly for lead acid battery. Okay, so what we are having, as I told, this lead acid battery will contain sulfuric acid and water. Okay, so we have a sponge lead, which is one of the electrode, and we have lead peroxide PbO2, which is another electrode. Okay, so if it is completely charged one, battery will look like this. As I said, when you are completely charging, it comes back to original position. So this is our original state when it is new or 100% charged. Okay, so you have this lead being lead, sponge lead, this electrode being lead peroxide, and the electrolyte is being sulfuric acid and water. Okay, so while it is discharging, what happens is there is a change of electrode and electrolyte taking place. Okay, so the composition is changing. How it is changing? Here it is simply a sponge lead. What happens when it is discharging? That is when you are supplying current, when you are using the battery, this decreasing the sponge lead, and there is increase in the lead plus lead sulfate. So there is lead plus lead sulfate is taking place. So this sponge lead is becoming lead and lead sulfate, and this electrode, which was simply lead peroxide, there is a decreasing in lead peroxide and there is increasing in lead peroxide and lead sulfate. Okay, so there is increasing in lead peroxide and lead sulfate. So that's what happens during discharge. And what happens to the even the electrolyte? There is increase in the water content. Why? Because sulfuric acid is decreasing. Why sulfuric acid is decreasing? Because there is lead sulfate formation deposition at the anode and the cathode. You can see that, right? So that way the sulfuric acid content in the liquid is decreasing, means in a composition X percentage is sulfuric acid, Y percentage is water. When X is getting reduced to 1 minus, X minus some, let me say some Z percentage has got deposited. So obviously the composition is changing, which means that the water content in the battery electrolyte is increasing. Okay, so that's what happened during a discharge process. What happens when you start charging? Okay, let's discuss continuously. When you have extremely battery from 100 percentage, we have reduced to 5 percentage charging. What happens is, here it is a minimum of sulfuric acid is there, a maximum of water is attained, right? And what happens in this surface? You are going to have a minimum of sponge lead here and a maximum of lead sulfate taking place, right? Similarly, at this electrode, you are going to have a minimum of lead peroxide and you are going to have a maximum of lead oxide. Okay, so then what will happen? You are going to, battery is empty, so you have to keep it for recharging. Okay, so when you want to do recharge, what will happen? So it will go back to its original position. That means what? Similar condition will be here. That is, you are going to have continuous increase in sulfuric acid. The reduction is lead sulfate at the both electrodes, and finally it goes back to its original state. So this is the cycle, operation cycle of a lead acid battery. Okay, so I repeat. So initially in the original position, You are going to have a sponge lead and lead peroxide, and the electrolyte is simply sulfuric acid and water. And when the battery is being in use, it discharging the power. In that case, slowly there will be increase in the lead sulfate uh, at the surface of these both electrodes, anode and cathode, and there is increase in water content because there is decrease in sulfuric acid. And when it is almost giving out maximum output, what happens with the time? Finally, we are going to have a maximum water and minimum sulfuric acid, and we will be having maximum lead sulfate at the anode and cathode surfaces. So what happens when you start recharging? Again, the sulfuric acid content in the water will increase. That means water percentage decreases and sulfuric acid percent increases. And finally, it will go back to its original position when you are doing the recharge, and it will have pure lead sponge, and you are going to have lead peroxide and sulfuric acid and water in the stage. So that is the cycle of a lead acid battery. Okay, so in this lecture we have seen what is electrochemical action. What is an electrochemical action? It is the process of converting a chemical energy into electrical energy. The anode is the positive electrode of a cell. The cathode is the negative electrode of a cell. Primary cell chemistry is the process in which the electrons leaving the cathode to the load cause a positive charge, which causes negative ions from the electrolyte to flow from that place to another electrode. So these negative ions will combine with the material of the cathode and form a substance such as lead sulfate, right? PbSO4 was formed in the lead acid battery. And what happens to the electron? So the electron from the load to the anode create a negative charge which will attract the positive ions, hydrogen from the electrolyte. What is secondary cell chemistry? It is a process in which the electrolyte acts upon and chemically changes both the electrodes, and this process also depletes the amount of active material in the electrolyte. A charging current applies to the cell, which reverses the process and which will restore the cell in its original condition. What is polarization? It is the effect of hydrogen bubbles surrounding the anode of a cell, which will increase the internal resistance of the cell. Polarization can prevent, we have to prevent the polarization by removing the hydrogen that is being formed by venting it. And also we can add some of the material which is rich in oxygen, what happens when hydrogen and that will release oxygen, hydrogen and oxygen will combine to form water and get released. Or you can even add some material which will absorb the hydrogen and which will again release it when you want it. Okay. And we have seen what is local action when there are impurities present in the copper. So there will be continuous flow of electrons even when there is no external load. So we have to prevent it by amalgamating with some material like mercury, right? And we have seen what is a dry cell. So it is the commonly referred to as flashlight battery, which is a dry cell. Since the electrolyte is not in the liquid form, but it will be in the present of new form of paste. The term dry cell is used because we don't have a liquid electrolyte there, where we are using a paste electrolyte. In most of the dry cells, the case material is the cathode. Okay, so cathode will be the case material, anode will be the center part. So this is a typical one. So typical dry cell, you can see a steel cover, positive terminal anode, negative terminal cathode, expansion chamber, depolarizing mix, zinc can, chipboard jacket, carbon electrode, asphalt saturated insulating washer, asphalt saturated paper gasket, like that. In childhood, we might have opened the battery to remove all these, and we might have seen it earlier. Okay, every one of us have done it. So the components of battery dry cell, we can see that. And what is the shelf life? Shelf life is a period the cell may be stored and still be usable. That means without being using, a new battery is made, but which is packed and kept in shop for a long time. But how long that battery can be there after? So how many days? Like after 3 months, 6 months, after 1 year, you buy the battery and keep it in your torchlight or anywhere you want to use it, whether it will be usure or not. That's what A shelf life is okay. A shelf life is a period a cell or battery can be stored and it will be still usable. Okay. So mercury cells should never be shorted because of the danger of explosion. That is one of the problem associated with mercury cells. And these dry cells are many types. Each will have its own advantage and limitations. The type selected for use depends on such factors as cost, size, ease at which it can be replaced, what is the voltage or current we require, right? And this lead acid battery or lead acid cell is the most widely used secondary battery, example for secondary battery. So this lead acid battery will produce electricity by electrochemical action. The anode is lead peroxide, the cathode is sponge lead, which I have demonstrated, and the electrolyte is sulfuric acid and water. We have seen that during the operation, the content of sulfuric acid decreases, water increases. When we recharge, again the sulfuric acid content increases. What is happening to the sulfuric acid? It is getting deposited at lead sulfate at the anode and cathode, right? And we have another example other than lead acid batteries. We have silver zinc cell, which is used mostly for emergency equipment applications. It is a lightweight, small, and has a large power capacity for its size. Usually, we use silver oxide as the anode, zinc as the cathode. And for this purpose, we use potassium hydroxide and water as the electrolyte medium. So, we are avoiding sulfuric acid here. Here, potassium hydroxide is used. Okay, so here H2SO4 plus water is the electrolyte. Here, KOH and water is the electrolyte. Okay. And another example is silver cadmium cell, as the name indicates. So it combines the better features of a nickel cadmium and the silver zinc batteries. So the anode here uses silver oxide, cathode is cadmium hydroxide, and here also KOH is used as the electrolyte. Okay. And what is a battery? A battery is a voltage source in a single container made up of one or more cells. As I shown you, a typical domestic application, we are using lead acid battery, which will have 6 cells. Okay, so it means depending upon the output voltage required, so each cell gives 1 voltage, 1.2 voltage means we are going to have around 6 volt. How much? 2 volt means 6 into 12, 6 into 2, 12 volt you will get. So accordingly, how much voltage you want, that much cell has to be kept. Accordingly, the cost of the battery will increase, right? And these cells can be arranged in different ways. Either it can be arranged in series parallel or series parallel. Accordingly, the output voltage and the current we are going to get different one. For example, series is connected. When you are connecting the cells in series, they will provide a higher voltage than a single cell, but there will be no increase in the current. Okay. So you can see the example. If it is a 601 battery is there. So when you connect like this, what happens? Okay. So this is a series connection. So this is parallel connection. So what happens in a parallel connection is they will provide you higher current, but there is no increase in the voltage. Output voltage will be the same because it is connected in parallel. It's similar to our centrifugal pump or pump connected in series or parallel, right? So if you want more discharge or you want more, okay. Here, when you can look at this series parallel connected cells, they will provide both higher voltage and higher current. So that way, so according to the requirement of what voltage output we want, what current we want to get, so accordingly, you can have it in series mode, parallel mode, or series parallel mode. Okay, so accordingly, you are going to get a different voltage and current. Okay. So if you look at our home batteries, you will be seeing something called as hydrometer. We'll look into it. So this type of battery can be determined from the nameplate data that is given from the manufacturer. That is what is the chemistry that is taking place. You can see, right? So you buy any battery, you can read about the things about it. Whatever is the battery thing, what is containing, whether it is made up of lead or any other material. Okay. So what is hydrometer? Hydrometer will provide note down the specific gravity of the electrolyte. Okay, that's why in your if your battery at home, you will see that in each hole, each chamber, there will be a hydrometer. So when it is totally coming up, you have to fill the water. If it is goes down or comes up, accordingly you will know whether it is empty. You have to fill it with the distilled water occasionally every 3 months or so. Okay. So ensure always check the battery in your home. Rechargeable means in your inverter battery. If you are having inverter, you have to check the water content. When the hydrometer position is changing, you'll come to know that it is water is drained. So you have to again fill it with water. Okay. Some of the words like we have to take care of safety precaution whenever we are handling with battery, because we've seen that most of the battery will have either KOH or sulfuric acid as the electrolyte. So both are will hurt you. So we have to follow all the safety precautions when you are using the batteries. Okay. So the capacity is an indication of the current supplying capacity of the water. One second. So what is the capacity? It is an indication of the current supplying capability of the battery for a specific period of time. So usually it will be an ampere hour. Okay, how much ampere hour it can give. So we'll talk about we want 400 ampere hour or 800 ampere hour like that. Okay, what is rating? It is the capacity of the battery for a specific rate of discharge. In most batteries, the rating is given for a 20-hour discharge cycle, 20 amperes for 20 hours like that. Okay. And what is battery charging? It is the process of reversing the current flow through the battery. Why we want to do that? We want to restore the battery to its original condition. So any addition of active ingredient to the electrolyte will not recharge a battery. Okay, so there are different type of chargings are there, which we have even discussed earlier also. There is initial charge, normal charge, equalizing charge, floating charge, and fast charging. So we have seen the advantages and disadvantages of the fast charging and normal charging in the previous lecture. And there is another problem associated with this thing is gassing out. Hydrogen gassing out is one of the problem which we have seen particularly during high temperatures. Okay. So what is gassing? Gassing is the production of hydrogen gas, which is caused by the portion of the charge current breaking down the water in the electrolyte. Steady gassing is normal during the charging process. Violent gassing indicates that the charging rate is too high. Okay. So we are having different type of primary cells and based on the cost, size, ease of replacement and voltage or current needs, many type of primary cells have been developed. So we have some brief description of some of the primary cells which are being used. Okay. So the primary cells, what is primary cell? A cell that cannot be recharged after its complete discharge. They are called as primary cells, and the chemical reaction in the cell cannot be reversed. And when you have n number of cells connected in series, they are called as battery. That is dry cell. The most familiar commercial cells are dry cells. These are used in torches, toys, TV remotes, and other devices. And they are based on Lagrange cell, which is invented by Lagrange. Okay. We already seen about these primary cells and Daniel cell. These are example of commercially available Daniel cell. What is a Daniel cell? It is a primary cell which cannot supply steady current for a long time. It consists usually of a copper vessel which will contain a strong solution of copper sulfate, and you will have a zinc rod dipped in it. Okay. In this zinc rod is dipped in the dilute sulfuric acid containing a porous part. So the porous part is placed inside the copper sulfate. That porous part will act like a membrane there. Okay, which will selectively allow the ions to pass through. So the zinc rod reacting with dilute sulfuric acid will produce zinc ions and 2 electrons, and the zinc ions will pass through the pores of the porous part and will react with the copper sulfate solution producing copper ions. What will this copper ion do? That copper ions will get deposited on the copper vessel. So when the Daniel cell is connected in the circuit, the 2 electrons on the zinc rod will pass through the external circuit and reach the copper vessel, that's neutralizing the copper ions. So this constitutes an electric current from the copper to zinc, and this type of Daniel cell is known to produce an EMF of 1.08 volt. So what is a Lagrange cell? So the Lagrange cell consists of a carbon electrode packed in a porous spot containing manganese dioxide and charcoal powder. So this porous spot is immersed in a saturated solution of ammonium chloride contained in an outer glass vessel. So the zinc rod is immersed in electrolytic solution. So that constitutes of the cell. So this type of cell reaction that is taking place is given here. Okay. So what happens is this ammonia gas will escape, the hydrogen ions diffuse through the pores of the porous plate and will react with the manganese dioxide. So during this process, the positive charge of this hydrogen ion is transferred to the carbon rod. When the zinc rod and the carbon rod are connected externally, the 2 electrons from the zinc rod will move towards the carbon, which will neutralize the positive charge, and the current will flow from the carbon to zinc, and they are known to have an EMF of around 1.5 volt, and it can supply a current of 0.25 ampere. So they are useful for supplying intermittent current. So if you differentiate between primary cells and secondary cells, these primary cells are irreversible reactions are taking place there, and they are not rechargeable, which means that it is a single use battery. And in primary cells, mostly they are dry fluids, that means dry cells, and examples are dry cells and Daniel cells. Whereas for example for secondary batteries are lead storage batteries, where the reactions are reversible, they are rechargeable, hence we can use it multiple times, and there are fluids are involved, so they are mostly wet cells or molten salts are used. Okay. So a typical dry cell will consist of a zinc cylinder which is filled with a moist paste of ammonium chloride and a little of zinc chloride. So the zinc cylinder will act as an anode. The cathode is a graphite rod. The carbon rod is surrounded by a black paste of manganese dioxide and carbon powder. The zinc case as an outer insulation of cardboard issue cases. During the usage, the zinc will get consumed. Okay. So this is a single-use battery. That means as the zinc is being consumed, the battery life will come to an end. So what is the reaction that is taking place at the anode? Zinc plus ammonium chloride will form zinc chloride and ammonium sulfate plus 2 electrons. And this cathode, you are going to have this aqueous solution coming to the cathode side, will react with MnO2 and the 2 electrons to form manganese oxide, manganese dioxide and ammonia. So this ammonia has to escape. Okay. So the overall reaction that is taking place is zinc plus ammonium chloride plus manganese dioxide will form zinc chloride plus manganese oxide and ammonia and water. Okay. So actually what is happening to the manganese? There is +4 oxidation state, it becoming to +3 oxidation state. And here the ammonia is formed, which is not liberated as a gas, but it is combining with some of the zinc ions and chlorine ions produced from the anode to form a complex ion having this formula, which will prevent the seal of the cell to crack because of developed pressure. It gives a voltage of around 1.25 to 1.5 voltage. So this dry cell does not have an indefinite life because of acidic conditions due to the presence of ammonium chloride being formed. So due to this action of H plus ions and NH4 plus ions, the zinc container will corrode even when we are not using this battery. So to avoid this difficulty, a modified form of dry cell, which is called as alkaline dry cell, has been prepared. In the alkaline dry cell, the electrolyte NaOH or KOH is used in place of ammonium chloride. So that way, alkaline dry cell means it will use a different electrolyte, which is sodium hydroxide or potassium hydroxide instead of ammonium chloride. Okay, so we will discuss about these mercury cells in the next lecture. I think it's time. Well, in this lecture, we have discussed about the basics of batteries, where we have seen the different components of a cell And what is the difference between cell and a battery? What is the difference between primary cells and secondary cells, or primary batteries and secondary batteries? What is wet battery, dry battery? We have seen demonstration videos for different batteries, and we have seen the chemistry and thermodynamics behind that, and we have seen what is over potential that is taking place, and what is the other issues associated with batteries performance. All that have been discussed in this lecture. Thank you so much for joining my classroom. Meet you in the next lecture. Bye bye.